At this point, let's talk about solving quadratic inequalities. It's a little different from solving quadratic equations. It takes a little more effort. First thing we need to do is just sort of get a method going. The right side needs to be 0. So go ahead and do that. If the right side's not 0, you need to get the right side 0. So that's going to be the first thing. The right side needs to be 0. Okay? Once you do that, solve the left side. Solve the left side, usually by factoring, but quadratic formula if you have to. Solve the left side, hopefully by factoring. Let's go ahead and get that far into this problem so we can start kind of understanding what's going on. The good news about this problem is that it's already greater than 0. So that's nice. It's greater than 0. So if I take the left side and I factor it, it will factor into x minus 3 and x plus 2. Also greater than 0. Now, if this were an equation, what would be my two answers? Positive 3 and negative 2. But this isn't an equation, this is an inequality. So what we do next can confuse people at times, so let's just go ahead and write it down. For step 3, I want you to make a number line with those solutions on it. I'm going to make a number line of those solutions. So over here, here's my number line, and on that number line, I'm going to put those two answers, and I'm going to just spread them apart a little bit so I have some room in between to work. So I'm going to put negative 2 here, positive 3 here. In this particular example, do you notice how that number line has been split into 3 pieces? It splits from negative infinity to negative 2, negative 2 to 3, and 3 to positive infinity. Yes? Do you see those 3 pieces? Okay. We don't know which pieces to shade. We have to figure them out. So once you've divided your number line into different pieces, you need to choose a test number in each section of the number line. So that's your 4th step. Choose a test number in each section. And it can be any number you choose. So let's go ahead and let's choose those numbers. Give me a number between negative infinity and negative 2.
Negative 3.
Negative 3, negative 4, negative 5. I try not to use giant numbers, but it really doesn't matter. I usually just pick something kind of close, negative 3 or negative 4. So let's use negative 4, negative 3. Is that okay? Negative 3? Let's use negative 3 as our test number. Tell me a number between negative 2 and 3.
0.
0. 1 wouldn't matter. It could be anything. Negative 1, 0, 1. You could even use a fraction or a decimal, but most students choose not to. 0 is fairly easy for us, so we'll use that one. And then you can pick any number between 3 and positive infinity. 4, 5, 6, doesn't matter. Choose those test numbers, okay? Take each one of them, plug it back into the original, and tell me whether it makes it true or false. You will take each of your test numbers, plug it back into the original, and you will mark on your number line whether that number makes the original problem true or false. So first we want to test negative 3. If I substitute negative 3 into the original problem, the left side gives me 6. So the left side gives me 6. I need to know whether 6 is greater than 0 or not, because that's what it says I want in the beginning. I would like the left side of that problem, x squared minus x minus 6, to be greater than 0. So if I plug negative 3 in, negative 3 squared is 9, 9 minus negative 3 is 12, and 12 minus 6 is 6. So the left side is 6, and then I want that to be greater than 0. In this case, that's true. So I'm going to know that everything in the same section of my number line with negative 3 should also produce a true answer when I plug back into the original. Let's test 0. If I put 0 into the original, 0 squared minus 0 minus 6 is negative 6. So the left side is negative 6 when I substitute 0 in. Negative 6, however, is not greater than 0. So that section of my number line produces a false response when I substitute those numbers in. And finally, let's plug in 4. If I plug 4 into the original, 4 squared is 16. 16 minus 4 is 12. And 12 minus 6 is 6 again. 6 is also greater than 0, so that section of the number line is also true. So what we have of these 3 pieces, the outer 2 pieces are true, whereas the inside piece is producing a false answer. So we're going to shade only where it's true. So I will shade this piece, and I will shade this piece, but I'll leave the middle section unshaded because it didn't produce a true response when I plugged into the original. Now we just have to decide whether we need parentheses or brackets. Because the original problem was strictly greater than 0, not greater than or equal to, both of these should have parentheses. And that's how we will solve quadratic inequalities. I know it seems long, but once you do a couple of them, it'll start to kind of sink in and make sense. It won't be so bad. So let's just finish up our notes here. After we check the test numbers into the original to see if it's true or false, we're going to shade only where it's true. Finally, we're going to write an interval notation based upon the graph we've shaded. In this case, my final answer is shaded from negative infinity up to negative 2. Then there's a break. Then I union it to 3, infinity. And that is the final solution set. That's the interval of answers that if I picked any number in that interval and plugged it into the original, it would make it greater than 0.